Homework time! Homework time is here again. And now we are on Module 2, that wee little module of just 5 lessons. Lesson 1 homework, here we go. Start, as always, by jotting down our name. So I will put my name, and you put yours. So when you turn in your work, you get credit for it. And then take a moment and jot down today's date. I will write today, and you write the actual date. And now what we're doing here is finding the equivalent measures. That's our instructions. You notice A through D here, we're dealing with kilometers and meters. And then when we get to E through H, we're looking at meters and centimeters. So let's start off by just taking notes here. You're probably remembering from today's lesson that 1 kilometer, sorry, that's kind of messy, but hey, it's just notes. 1 kilometer is 1,000 meters. And in a way that's kind of hard to picture. Let me grab my meter stick here just to give you a sense of what we're talking about. So here's a meter, right? That's easy to picture, 1 meter. But 1,000 of these lined up end to end, I don't know, that's kind of difficult to imagine. So think of it in terms of like the kind of things you'd measure in kilometers are the kind of things that you would measure in miles. So we're talking about distances, not linear measurements in the sense that you take a ruler, you take your kilometer ruler and line it up with something, it's just too far. So this would be like the distance from your house to, the big box store or the mall, or the distance from your town to the next town, that kind of thing. We're talking about kilometers. And 5 kilometers is a common running race, very popular running race length. So if you look at this, 1 kilometer, we said, there's our 1 kilometer. I'll make it big and heavy. 1 kilometer is 1,000 meters. Then 5 kilometers would be 5 times as much in terms of meters. So 5,000 meters. We see how that works? Okay, good. Now you see we're going to cruise through these. Now we understand what we're doing. And then the 13 kilometers will be 13 times as much as this right here, as our standard conversion. So 13 kilometers, 13,000 meters. Not so bad, huh? And then we're asked to do it in reverse. So how many kilometers would be 17,000 meters? 17,000, you got it, 17 kilometers. And one more time, we're going to go from kilometers to meters. So 60 kilometers, what would be 60 times 1,000? 60,000. Or instead of saying 60 times 1,000, which is correct, you can think of 60 1,000s, 60,000s, 60,000. Which, again, like I said, is pretty well impossible to picture for most of us. All right, we can sort of imagine it, right? Well, this is much easier to visualize on the centimeter side because this meter stick here is 1 meter and it's 100 centimeters. So that we can picture. So we can make our little note here as well that 1 meter is 100 centimeters. And you probably already learned what all these prefixes and such mean. That centi means 100 or 1/100th, and that kilo means 1,000. So I won't go over that all again for you, although I just did, huh? Anyway, so 7 meters would be 7/100 centimeters, right? So 700. That makes sense? So if you're looking at one of these meter sticks, that's 100. 7 of these meter sticks would be 1, 2, 3, 4, 5, 6, 700 centimeters. And so now the next one is easy to do because you say 19 meters will be 1900 centimeters. Do you see the beauty of it all coming together? Everything we do at place value, we are using. Now you see why you did it, because now when I say 1900s, you know exactly what I'm talking about. Isn't that beautiful? So 1900 centimeters. Drop that comma. And now we can do it in reverse as well. So how many meters would be 2,400 centimeters? And I'm saying it that way on purpose. I could say 2,400, but I want to say 2,400 centimeters, because when I say that, you hear that 24 hundreds. Ah, yes, so it's 24 meters. Ooh, you're good. You're hot today, you're hot. All right, 90 meters. We can use the same logic and say that would be 100 centimeters, right? 90 meters is 90 sets of 100 centimeters. 90 hundred in standard form, 90 hundreds is 9,000. Pretty cool, huh? The way place value and this whole metric schema will work together. Let's roll on to number 2. And in number 2, we're doing the same thing, but with a little spice added here, a little garlic salt, one of my favorite spices. We are still going to find the equivalent measures, but now we have, instead of just, say, 7 kilometers, we have 7 kilometers, 123 meters. And so you'll find that this works the same way. 123 meters is 123 meters. So imagine if the 7 kilometers weren't there, and it said 123 meters equals blank meters. 123 meters equals 123 meters. It's that easy, my friends. And now the 7 kilometers, we already know from up above, is 7,000 meters. And putting it together with the 123 meters, so you see how that works? 7 kilos, 7,000 meters. In fact, if you read that kilometer, if you read that kilo prefix as thousand, you literally have here 7,000 meters, 123 meters. 7,123 meters. All right, now the rest will be easy for you. But look at this one. This one, they're throwing a little pepper in with your garlic salt. So we know, okay, 22 kilometers is 22,000 meters. We've got that down, right? But then the 22 meters, if I write 22 comma 22, that's not like a real mathematical number. There's no hundreds, are there? There are no hundreds. And so I will place a 0 in the hundreds place. 22 meters is 22 meters, my friends, every day of the week. So you need that 0 there. That's the only thing that's a little tricky there. And now here, 875 kilometers, well, exactly. Times 1,000 is how you could think of it. So 875,000. And now the 4 meters, as we just saw in B, we have no hundreds and we also have no tens this time. So 875,000. No hundreds, no tens. 4 meters is 4 meters, right? Okay. And now the same thing works in a different fashion with going from meters and centimeters to centimeters, just that our basis, our principle is 100 instead of 1,000. So look at this first one. We know 7 meters is 700 centimeters. And then if you look just at 45 centimeters, 45 centimeters is 45 centimeters. So then this would be 745 centimeters. Now in the case of 67 meters, we know that's 67 hundreds, right? 6,700. And then 7 centimeters will go in the ones place. So 6,700, we have no tens. And then 7 centimeters is 7 centimeters. It's a tongue twister. 7 centimeters is 7 centimeters. Say that 5,000 times fast. No, don't really. So 204 meters will be 204 hundreds. Okay, so one way to think about this, to kind of picture it so you don't get confused, because the mistake here would be to write 204,000, right? That you might have been thinking that. But make it so that the 4, because we're saying 204 hundreds, make it so that that 4 lands in the hundreds place, like this. Watch, I'm going to write 204 meters is 204 hundreds of centimeters. So this 4 is in the hundreds place, so my comma goes between thousands and hundreds, right? Now I can continue writing the number. 89 centimeters is 89 centimeters. Ah, you see the beauty there? And if for some reason, if this had been like 9 centimeters, instead of that 8 in the tens place, I would have a 0, right? So we can see 204 hundreds is actually 20,400, and then we have the 89 centimeters. Get it? Yeah, all right, well, don't worry. If you're not fully there, we're only on number 2. Let's move on to 3. All right, in number 3, this is a beautiful thing because we're taking everything we did in Module 1 with place value, addition, subtraction, and now utilizing those skills you gathered in Module 1 to do these metric conversions here we're just working with distance and length measurement. Isn't that great? You're actually using what you learned. It's a beautiful thing. So now, in order to add and subtract in all of these, we have to be talking about the same thing. So like in this first one where we have, our instructions are solve, where we have 2 kilometers, 303 meters, minus 556 meters. Well, that's a little tricky to do as it's written. So what I'd like to do is convert this kilometers and meters to just straight meters. Then I can subtract. And I also want to write this vertically, up and down, instead of horizontally, because that's how we do the standard algorithm, right? The usual way of figuring out subtraction. So I know 2 kilometers is how many meters? We just did that up above, didn't we? That's 2,000, and we also have 303 meters, which you will be shocked to find is 303 meters. So 2,303. And when you're doing the calculations, you don't write the units, just when you write your final answer, by the way, or just clutters things up, it gets confusing. And then I'm going to subtract from that the 556 meters. So now everything's expressed in terms of meters. Now I can do it. All right. So can't take 6 from 3. See, look how we're using what we learned. So I go to tens place. There's a 0 there, so I'll keep going to the hundreds. I will leave 2 of those hundreds there and bring 1 over as 10 tens, but I still need to do something to help myself in the ones place. So I will leave 9 of those tens there and bring it over, 1 of those tens over as 10 ones with the 3 ones already present in ones place. And now I can subtract. 13 minus 6 leaves 7. 9 minus 5, yes, is 4. And see, they want to make sure you haven't forgotten how to do all this regrouping, decomposing stuff. So here we can't take 5 from 2, so we'll go to thousands place. I'll leave 1 of those thousands, and the other 1,000 will bring to the hundreds place as 10 hundreds, joined with the 2 hundreds still there, is 12 hundreds minus 5 hundreds leaves, you got it, 7 hundreds, and then 1,000 minus nothing there is 1,000. So our answer is 1,747 meters. And where you have 1,000 meters, you can also express that as, yes, 1,000 meters is a kilometer. So our a better answer would be 1 kilometer, and right, 747 meters. And this should be a lowercase k, just in case I draw that correctly there. That's a lowercase, trust me it is. All right, and now this one will definitely, you can tell we'll be doing some regrouping right off, right? So 2 meters, now here we're dealing with centimeters, okay? So we got to click it back to that 1 to 100 ratio, okay? So 2 meters is how many centimeters? Remember the meter stick, this is 100, so 2 of these would be 200 centimeters. Okay, so 200 centimeters minus 54 centimeters. And this time when I subtract across that 0, I'm going to do that little shortcut which we learned back in the first module and skip the writing a 10, crossing out writing 9, because I know that's what I have to do. So I can't take 4 from 0. I'm going to decompose through this 0 to the hundreds place. We'll leave that 100 there. And again, here I am skipping that little 10, cross out, write 9, and just writing 9 because I know that's what I'm going to be doing. And then that 110 I'll bring over to the ones place as 10 ones. Got that? Yeah, that makes sense. All right. 10 minus 4 now is 6. 9 minus 5, 4. And we're taking nothing from the 1, so 146 centimeters. And where you have 100 centimeters, that's one of these, right? That's a meter stick. So we could say 1 meter, 46 centimeters. Both answers are the same, right? They're both correct. Okay, now here we're adding, and it says specifically to express our answer in the smaller unit. The smaller unit is meters, right? So in this case, we'll just give it straight answer in meters. And so that means we should convert everything to meters, which is what we do anyway. So 338 kilometers is 338 kilo means 1,000, 338,000 meters, 853 meters. So 338,853 meters. And we're adding to that 62, kilo means 1,000, 62,071. You see why we did all that place value stuff? 62,000. Yes, yes, you got it. Put a 0 in that hundreds place. There are no hundreds there. 71 meters. And don't forget, we are adding. So let's do that. 3 and 1 make 4. 5 and 7. Got it? Yeah, 12. Regroup that 1. 1 and 8 and 0. 9. 8 and 2. 10. Regroup that 1 and drop that comma over here. 1 and 3 make 4. 4 and 6 make 10. Good. And regroup that 1. 1 and 3 make 4. Okay, and so we're expressing it in the smaller unit as meters. So there we go. That's meters. Although you can tell it would be 400, where it says 1,000. That comma says thousands to us, right? That's what it signifies. That's the break between 100,000. It would be 400 kilometers, 924 meters. But we're going to do it the way they said. And here again, we're doing the same exact thing, except we're subtracting. So I want to make sure I leave a little room at the top above, which I didn't do a great job of before, so that I have room to do all that decomposing and subtraction. So again, we're going back to centimeters though, so our ratio is 1 to 100, not 1 to 1,000. So 800 meters is 800 hundreds in centimeters. So again, a way to think about that is that 0 of 800 will land in the hundreds place. This is the hundreds place. And I know the comma goes between hundreds and thousands. You see, that's a way of thinking about it? And then 35 centimeters. So this is all in centimeters, because it's said to put in a smaller unit, which of course is the centimeters. And now I'm subtracting from it. Okay, same thing. 154 meters in centimeters is 154 hundreds. So I'm going to write 154 hundreds, right? That 4 is in the hundreds place. My comma goes between thousands and hundreds. See how that works? And then 49 centimeters. And we are subtracting. Cannot take 9 from 5, so we need to do some decomposing, leaving those 2 tenths there, bringing 1 over as 10 ones with the 5 ones already present. Gives us 15 minus 9, which leaves 6. Good. Can't take 4 from 2. Now we have to go and regroup across zeros, going out to the 8 and the 10 thousandths place, leaving 7 of them there. And again, here we go. I'm going to skip that step of writing a 10 and immediately crossing it out and just go right to, I know I'm going to have to make it a 9, right? Because I'm going to decompose 1 from there. And I'm going to have to do again in the hundreds place so that I can bring over 10 tens to the tens place. Join with the 2 already there. I hope you can read that all right. It's 12 tens minus 4 tens leaves 8 tens. 9 hundreds minus 4 hundreds is 5 hundreds. 9 thousands minus 5 thousands is 4 thousands. Drop that comma while we're in the neighborhood. It's a beautiful day in the neighborhood, isn't it? 7 minus 1 in the 10 thousands place leaves 6. And this is what? The smaller unit. This is centimeters. Very good. All right, now here, 701 kilometers. Remember that kilo means thousand, so you can just say to yourself, 701,000 meters. See how the metric system's beautiful. I love it. It's so logical. 701,000 meters. Those are zeros. I'm sorry, they're not beautiful the way they should be. Oh, I don't think I improved things. All right, anyway, 523,000 meters, 445 meters. So 523,445 meters. And we are subtracting. And you see we have lots to do across zeros here, so going out to thousands place, leaving 0 there. And again, here we go, skipping that little step of writing 10, crossing out, writing 9. Writing 10, crossing out, writing 9. And just going straight to the 9. I know I need to regroup 1 over to tens place. And then I need to regroup over here to the ones place. And that's where 10 is going to be. A common mistake is to write another 9 in the ones place. Just write 9 straight across. If you find yourself doing that, then don't skip the step we're skipping. Go back to writing 10. I'm going to leave 9 there and regroup 1 over to this place and write 10. Okay, so you're doing it, breaking it down into each component before you start skipping steps, if you're making that mistake. Or just whatever, don't make that mistake. All right, 10 minus 5 is 5. 9 minus 4, again 5. 9 minus 4, okay, yeah, still 5, okay, good. And we can't take 3 from 0. Common mistake there, again, is to write 3. So again, we have to regroup across the 0, so we will leave 6 of the 700,000s. And here we go, skipping that step, writing 9 in the 10,000s place so we can write 10. I shouldn't have crossed out that little 0. And write 10 in the thousands place. 10 thousands minus 3 thousands leaves 7 thousands. Drop that comma while we're here. 9 minus 2 in the 10 thousands place leaves 7 10,000s. And 6 minus 5 is 1. And here we're talking about meters. Now in this case it does not say to express it in the smaller unit. So I'm going to make it. You see how this 177,000, that would be 177,000 meters, 177 kilometers, 177 kilometers. All right, 177 kilometers, and then 555 meters. Because that's how we were given the example, right? That's why I'm writing it that way, in kilometers and meters. And now, one where we're adding, and this one is actually, it looks like it's going to be the hardest one, but it's actually probably one of the easier ones here, because 231 kilometers, and we're dealing with kilometers and meters here again, we know is 231,000 meters, 811 meters, and then 485 kilometers, 1,000 meters, 1,829 meters. And we are adding, which tends to be easier, right? 1 and 9 make 10. Regroup that 1, 1, 1, and 2 are 4. 8 and 8 make 16. Regroup the 1, 1, 1, and 5. Yeah, 7. Drop that comma. 3 and 8 are, that's right, 11. Group the 1 there. 1, 2, and 4, 7. Okay, 717,640, and that's meters. So again, to put that into kilometers and meters, quite simple. 717,717 kilometers. And I'm making my K's look lowercase now. Aren't you proud of me? 640 meters is 640 meters. Wow, number 3 was kind of involved there, wasn't it? It took a little while, but you did it. You got through it. Good work. Let's go on to number 4. All right, in number 4, we get to the word problems where we apply what we've learned. And I ain't gonna lie to you, friends, this is a long, arduous homework session here, okay? So, just like we even had back at the beginning of Module 1, right? It's a bit of work, but you're tough. You can handle it. All right. So we're going to use a tape diagram to model each problem. Solve using a simplifying strategy or an algorithm, and write your answer as a statement. We're going to stick with the algorithms, adding and subtracting in the usual way. The length of Celia's garden is 15 meters, 24 centimeters. The length of her friend's garden is 2 meters, 98 centimeters more than Celia's. What is the length of her friend's garden? So we're not looking at any other dimension of the garden besides the simple length of it. So when we look at Celia's, we're just given that. Okay, here it is. And I'm going to do myself the favor. I know when I go to do the math that I'm going to want to have these all in, it's kind of our simplifying strategy here, have these all in centimeters. So I might as well just do that now. Remember, we're talking about meters and centimeters, so our ratio is, like on a meter stick, 1 meter is 100 centimeters. So it's 1 to 100. So 15 meters is 1,500 centimeters. So when I write 15 hundreds, the 5 is in the hundreds place. 24 centimeters. See, that's 1,524 with the all in centimeters. See, so I'm combining that step right into the tape diagram. And now friend, apparently nameless, so we'll just put an F for friend, is hers more or less than Celia's? Yes, we're looking at the length of her garden, and at least that, F for friend, is more. Yeah, but Celia's not jealous. Her carrots have come up better. So we don't know how much the whole thing is, but we do know this part, right? We know that I can even put a little dotted line down through here, right? I know that this part, how much more it is 2 meters, 98 centimeters. And again, I'm going to go right to centimeters with that. 2 meters is 2 hundreds in centimeters. 200, and then the 98. So 298 centimeters is the difference. That's how much more it is. So obviously, to find what we're trying to find here is the full length of the friend's garden, and we can see, and let's call that G for garden. We can see that it's going to be Celia's plus how much longer hers is. So we are going to be adding. See, that's why we draw a tape diagram, my friends. It's not just to make you suffer, although that might be a part of it. No, just kidding. It's so you can see what you're supposed to be doing mathematically. You can say, okay, I can see I have to add these because it's Celia's plus how much longer her friend's is. All right, so let's do the addition here. 4 and 8 make 12. Regroup that 1. I see a pattern here. 1 and 9 make 10. 2 more is 12 again. Regroup that one. 1 and 5 and 2. 8. Very good. And 1 with nothing is 1. Drop that comma. And so the length of her friend's garden we see is 1,822. Yes, always affix those units. Yes, centimeters is what we're talking about here. And now we need to write a statement. But take a moment first and think to yourself, okay, this many centimeters, well, we started off with meters and centimeters, so that's how we should end up, right? And so we look at the hundreds. How many hundreds are there? And notice, see where I'm circling here. Yes, there's an 8 in the hundreds place, but that wasn't my question. It said how many hundreds altogether are there? There are 18 hundreds. So 18 hundreds is, yes, 18 meters. Very good. 18 meters, 22 centimeters. So her friend's garden, we have to do our statement now, actually answer the question, which is what is the length of her friend's garden? And note the spelling of friend. Her friend's garden is 18 meters, 22 centimeters long. It's a song about a garden and a friend. Let's rock on, friends, number 5. So here we are, number 5, and this is a good place to stop and mention that if you find a little homework fatigue setting in, you're getting kind of like a little antsy, a little fidgety, a little sick, you find yourself sick of doing it, and you find yourself taking shortcuts you really shouldn't be taking just to get done, what you can do is set up a mini reward system. You could even say, after I finish this word problem, I'm going to get up and go get myself a cup of milk and look out the window for 2 minutes or whatever it is. Just like get up, walk around, and come back and then do the next one. And when I finish that one, I'm going to, go get myself a cookie or something. Like work out a little reward system. Even if that reward is just getting up and walking around, it's not really useful to say, I'm going to force myself to sit here until it's done and I will not budge. It's better to get up, get the blood circulating, take that miniature break. You can't go off and play an hour of Fortnite in between each example. That's not quite what I'm talking about. But a little reward, a little break. I'm going to go get myself a spoonful of peanut butter. I like that. What? All right, whatever. Here we go. Topic in number 5 is near and dear to my heart, running. Sylvia ran 3 kilometers, 290 meters in the morning. Then she ran some more in the evening. If she ran a total of 10 kilometers, how far did Sylvia run in the evening? So we have morning and evening, so we're going to set up 2 tapes. Here's morning. We have an exact value for that. And again, it's not skipping anything. We're just going to be smart and do what we know we have to do now, which is to put it all into meters. There's going to be a way to work more easily with meters and kilometers. So 3 kilometers, 3 kilometers, 3,000 meters. Okay, see how that works? So this is 3,000, and then we have 290 meters. And then in the evening, we don't know how much she ran at all. In fact, we don't even really know if it's more or less, although you're savvy enough, you can do a little mental estimation. Say, oh, this is about 3,000 total of, 10 kilometers is going to be 10,000 meters. We can jump ahead with that. So it's going to be 7,000. So actually the evening run is substantially more, about double even. I'm not going to draw it quite that long. I won't leave any room to do my math. But so I just, if you drew it shorter, would it really matter? No, it wouldn't be accurate, but it wouldn't hurt anything. However, we do not know exactly how much she ran in the evening just yet. But what we do know is the total. See, and this is the beauty of the tape diagram, is that it shows you what everything means. The total, the 2 runs, the morning and evening runs together, are 10 kilometers, which I already spilled the beanos there. kilometers, kilometers, 10,000 meters. 10,000 meters. And what we're trying to find here is E, the evening run, okay? So we can see this is a simple case of what? We have the whole, we have a known part, we're looking for an unknown part. Yes, that indicates we need to subtract. So if you take the whole run, the 10,000 meters, and subtract the known part, the 3,290 meters, we will get the unknown part, the evening run. Now, if you did this backwards and you added, you would get, 13,290, right? We can see that right off. And you'd say, well, hold on. How could she have run more in the evening run than she ran all day? That makes no sense, right? So it doesn't pass the does my answer make sense test. All right, so let's get into the subtraction. Groovy. 0 minus 0 leaves 0. And now we could see right away we are going to be doing some regrouping across the zeros. So as we go across here, we finally get to 10,000's place. We will leave 0 10,000s. And again, we're going to skip the writing the 10, crossing it out step. We're going to put 9,000s, bring over 900s, and one of those hundreds there, that was the 10, we will bring to the tens place as, that's right, 10 tens, which is equal to 100. And just to pause for a moment here, 10,000 is actually equal to, look at each place, 9,900 plus 10. 10 in the tens place is 100, right? So 9,900, 100 makes 10,000. So that's all we did. We didn't do any magic. We didn't make it, although we say that make this a 9. We didn't make it anything. We're just decomposing, moving the numbers around to help us to subtract, which we will now do. 10 minus 9 leaves 1. 9 minus 2 leaves 7. Good. 9 minus 3, 6. And we see we have a 0 in the 10,000s place. Drop that comma. And this is in what unit? Meters. But we were given our original question in meters and kilometers. So let's do that with our answer. 6,000 meters is 6 kilometers. Good. And 710 meters is still 710 meters. All right, and then we just simply need a statement to wrap it up. Sylvia's evening run, that's what we were trying to find, was 6 kilometers, 710 meters. Period. Done. So if you're going to go get a cookie, do that. Get right back here, okay? Finish up this homework. We'll go on to number 6. All right, we got more people running around like crazy folk here in number 6. Jenny's sprinting distance was 356 meters shorter than Tyler's. And then we're given Tyler's. Tyler sprinted a distance of 1 kilometer, 3 meters. So how many meters did Jenny sprint? Okay, so let's actually start with Tyler, because that's what we know, right? So Tyler, his distance, and again, as I've done the other ones, I'm going to go straight to converting this all to meters because I know I'll need to do that. So might as well take care of that business now. 1 kilometer is 1,000 meters, right? And then we have also 3 meters, so 1,003. And I'll note that that's meters here. And now Jenny, was hers longer or shorter? Yes, it was shorter. Okay, so when I draw J for Jenny, all right, I'm going to make it shorter. And I don't know how much Jenny's is. That's what I'm trying to find. That's my J variable here. But I do know this, right? I do know the difference between them, that it was what? 356 meters. And so now I can clearly see from my tape diagram that if I take the whole, subtract the known part, I'll get the unknown part. You see how that works? So let's do that. 1,003 minus 356. And you see we got some regrouping to do here. Splendiferous. All right, so we can't take 6 from 3 without doing some decomposing. So we'll take this 1,000, leaving none. And here I'm going to do it step by step so you don't get confused. I bring it over as 10 hundreds. That still doesn't help me where I need it, so I'm going to leave 9 of those hundreds there. Bring over 1 of those hundreds as 10 tens. Yep, it still doesn't help me in the ones place, so I'm going to take 1 of those tens, leaving 9 of them, and bring it over to the ones place as 10 ones, joined with the 3 already there. So you see why we often skip the step of writing the 10 and crossing it out, because we know we're going to do that anyway. So 13 minus 6 we can now do leaves 7. 9 minus 5, 4, good, and 9 minus 3 is 6. And this is what unit? Meters, okay? Now, can we convert that to kilometers and meters? No, we can't really. I mean, you could technically, but there's no need to here because we don't have 1,000 meters that would make a single kilometer. Okay, so it's just 647 meters. So, and that makes sense here, right? When you look at it. In fact, if you round, this would be 600, this would be 400, 600, 400. This rounds to 1,000. It all works out. So Jenny sprinted. Nice simple statement here. Number 6 was mercifully easy on us. Jenny sprinted 647 meters. Period. Done. Number 7 awaits. Number 7 has us moving from runners to electricians. Naturally. All right, let's do it. The electrician, the electrician, I guess he's just the electrician. He's not Bob the electrician, it's just the electrician. Anyway, he had 7 meters, 23 centimeters of electrical wire. He used 551 centimeters for one wiring project. How many centimeters of wire does he have left? And note that we're asked to express our answer in centimeters. So that's what we'll do. So to draw this out, let's call it W for the wire he starts with, right? And that is a known quantity, but let's put it all in centimeters because we know we're going to have to do that. So again, now remember our ratio, meter stick, 1 meter is 100 centimeters. So 7 meters is, right, you got 700 centimeters. With these 23 centimeters is 723 centimeters. Good. Okay, so now for the project, and we'll call that P, he used, that's right, and we're told that, and we're told it already in centimeters, and we see it's a value less than the 723. Okay, so it's 551 centimeters. And so we're trying to find how much he has left. Okay, so that's going to be the difference between them, right? All right. All right. That's what's left, is that part of it. And you can even see, like, if this were actual wire, like, okay, you use that much of it, right up to there. And so that's our unknown. That's what we're trying to find. I don't know, what do we want to call that? Let's just call it X. When in doubt, call it X. Okay. And so we can see clearly from our diagram that if we take the whole, subtract the known part, we will get the unknown part. And this one, again, usually these get more difficult as you go along. This homework, they really aren't, I don't think. All right, so 723 centimeters minus 551 centimeters. 3 minus 1 is 2. Wow, we didn't have to regroup. Imagine that. All right, 2 minus 5, however, yes, there we need to. Okay, whew, that's a relief. All right, so we will leave 6 of these hundreds and bring 100 over as 10 tens, joined with the 2 tens already present in the tens place, gives us 12 tens minus 5 tens, leaves 7 tens. And then 6 hundreds minus 5 hundredths is 100. And a quick rounding here will show this to be true. This would be 600 plus 200 is 800 and 700, so our answer is reasonable. That's close enough. 723 is close enough to an estimate of 800. It makes sense. And what's our unit on this? Yes, we're talking about centimeters. So the electrician, we'll just say he, because it does identify him as male, he has 172 centimeters of wire left. Well, there you go. You done it again. You finished your homework. And congratulations. That was a good, big, long, arduous exercise. I think you deserve a little reward. Maybe another glass of milk. All right, see you next time. It's homework.